Okay, it's moving at a velocity v. Okay. Yeah, I'll call it v. Okay. Okay. So that's all you need to focus on. Are we clear? Okay. Before we go on, any idea what's a gear? You all have done 2DO3, yes? Have you all done gears in 2DO3? Hey? This week. So have you all had the intro of gears yet? Ay. Who? The instructor was sick last week. Yeah. Okay. It's okay. So let me quickly go through gears. Question for you, what is a gear used for? Anyone? Why do you use gear? Come on, tell me the obvious one. Yes. Huh? What sort of mechanical advantage or disadvantage? A gears has advantages and disadvantages. So tell me the mechanical advantage. What are they? Yes. You're right, but let's focus on spur gears for this case. I'm not saying that you're wrong. What are gears used for? Yes. Okay, so gears are known as speed increaser or speed reducer. When it is a speed increaser, you have to notice that torque is what? Reduce. When it's a speed reducer, torque is what? Increase. Now, let me ask you another simple difference, okay? What is the formula for torque? Yes. Torque is equal to force times radius. So if you have a circular shaft, this is your instantaneous axis. You have a force applied here, and this is your what? This is your radius. Now, can someone tell me the formula for moment? Yes. What sort of distance? What sort of distance? Yes, it's equal to force times perpendicular distance. Okay. So now you have two topics. You learn this in 2DO3 and you learn this in 2PO4. Am I right? Yes or no? What is the unit for torque? What is the unit for moment? Are they the same? They are not the same. How many of you think that it's the same? Some department in the Faculty of Engineering say it's the same, and that pissed me off. Number one, what is the difference between a torque and a vacuum moment? Spelling. It cannot be the same thing. The second thing that's the most, I mean, by looking at it, you know that force is equal to Newton meter. Moment is also equal to what? Newton meter. Has to be the same. You look at the Oxford Dictionary, it's not the same. But we are engineering. We are not arts or history students that we focus on one. Well done, sunshine. So what is the difference? Get this clear, up to today, okay? Some department, no name mentioned, in the Faculty of Engineering says that it's the same, and I'm going ballistic. That's why I'm so sensitive. What is the difference? Some of you have done 2C or 3C with me. You know the difference. Some of you have not. It's okay. So if you look at moment, if we have a beam that is a cantilever beam, right? This is our cantilever beam. Okay. We have point A and we have point B, and we have a force applied down here, P. Right? We have a force applied on the top P. How will the structure deform? Anyone? How will the structure deform? It will deform like a set face, right? It will deform like this. So this is our deformation pattern. Okay. And this axis, I want to tell you, this axis is known as our, I forgot the name. Wait. Neutral. Sorry, this axis is known as our centroid. Okay. That axis is known as our centroid. Okay. Now at point A, you know, at point B, what we have is we have a force coming down. This is moment Z at point B. Okay. So if this is my transformation, X, Y, rotation about Z. Okay. Now, what are the reaction at point A? Can you remember? Don't remember. Can you all visualize? At point A, the rotation will be going clockwise or anti-clockwise. Those of you who are not sure, don't worry. Is it going this way or is it going down this way? Anyone? Okay, so if you're unsure, it has to be in this direction. Are we clear? Why this direction? Based on which law? Newton's. I punch you, you punch me, same strength, different what? Direction. Newton's what? Third law. Nothing to memorize. If you're going to memorize this, we should not be here. Are we clear? Okay, nothing to memorize. Action equal reaction, same in magnitude, different in direction. That's why this is the moment at point where? At point A. And then we know that this is what? We have a reaction at AY. This is what we call a moment. What's talk? See, up to today, yeah, I got disorder. That's why my wife told me to like relax on my discipline, my daughter, you know. Really disordered. Talk. Okay, watch this. When the torque is applied, okay, so over here, this is our center. This is our force what? P, right? And then we have a what? We have a what? Radius, yes or no? Right? Over here, in moment, we also have a force, and then we call it a moment because this is applied perpendicular to the what? Centroid. That's why we call it perpendicular distance. Radius over here is also a what? Perpendicular what? Distance. The difference is this. When I start drawing this in 3D now, right? T times R is going to generate a motion known as torque. Okay, this is what torque is. Yes or no? Wait. Now, if I were to construct, okay, if we were now to construct, this is my centroid. Now, how will the centroid deform? how will the centroid deform? Is it going to be smiling face or is it going to be sad face? Neither. It will stay on the same. Be clear. It will stay on the same point. When I deform this, the centroid will not shift at all. Are we clear? So how a particle will react? Okay, how a particle react is if a particle initially is over here, the next displacement is over here. This angle over here is how the structure deforms. This angle is known as your gamma angle. Dr. Koshi will teach this in talk in when? Are you all learning talk now with Dr. Koshi or not yet? Not yet. When he teach your talk, this is talk. Now, can you see the distinct difference? Yes or no? Can you all see the distinct difference between force, between moment and torque? Get this very clear. The prof that's teaching this is in engineering physics. They can screw it up. Mechanical engineer, we cannot screw this up. Are we clear? Okay, we don't. Yes. Centroid is determined by geometry, which you will learn within 2P and 3A. For now, just take it as a centroid. Okay. Yes. Now, there is a moment over here acting in this direction because force times perpendicular distance. Why is it in this direction? Is because of Newton's third law at the fixed end. Yeah. Okay. And moment at point A. Okay. Yes. Say it again. How's the deformation pattern of the centroid? Over here, the centroid did not move at all. The centroid stay at the same point. Sorry, when I get excited, I explain this not very clear. Okay, over here, I'll write this out. So as a torque, there is no deformation at the centroid. Over here, the deformation pattern is either a smiling face or a what? Or a sad face. Okay, that's how you differentiate. Are we clear? Very different, very, very different. Okay, don't say it's the same. Right. So now we all know where are we. We now know the difference between the torque, what is a gear used for, and what is something else that the gear is always very useful. Anyone? Yep, is used to change the direction between the driver and driven. Okay. Again, you come with two new terms. What you see down here, you see a term driver and you see another term what? Driven. Okay. So what is a driver gear and what is a driven gear? Okay. So back to this diagram over here, right? Back to this diagram over here, you can zoom in. So we know that over here, maybe you don't know, but I'll tell you now, this is our what? Motor. Okay. The motor is to drive gear what? A. So gear A is the what? Driver. Gear B is known as the what? Driven. And then there's a formula that you all have to know. Okay. And I was hoping that you all learn gears already. There's another formula that you have to know, that velocity is equal to omega A RA, and it's also equal to omega B RB. Okay. And then there's another formula for gears is always true, where the angular displacement of A RA is equal to the angular displacement of B RB. Okay, and
This is in radians. Okay, always remember that. Okay, coming back to our current problem now. Okay. Okay, so now you know everything about gears, and if I were you, okay, you need this knowledge to do any of the questions regarding gears. Are we clear? Okay, you need to have this knowledge. Okay. Now coming back to our problem now, I'm going to copy this whole thing. Okay, I'm going to get this information across. Because without those information, we no picture. Ay. Always making a mess. Order, send it to back. Okay. Okay. So what is given to us? Okay.